My name is Juning Hu, and I'm very happy that 3 speakers before me, they laid the foundation for everything I'm going to say. So I've been building data agentic platform and also lead the data platform before. So today what I want to share with you is how we can build the agent native data platform, meaning how we support as we see agent become more and more in every enterprise. You essentially, humans will become more like in the supervisor background role, and the agent will execute the most task for different companies. And that means the future is going to be a platform that support agent interaction. Oh, how do we do? 1 second. All right. So the traditional data platform, or we talk about traditional platform, was built for humans. And whether it's for human to do analytics, you access data, you retrieve data, that's a human task. Or application. On the application side, you write an API, access the data to execute the task. In all of this, there's problems for agent. Number one is all the systems are siloed. For example, you have ERP for your payroll, for enterprise system. You have a customer relationship for sales. You have data warehouse for your transaction, for customer data. You have files that has a company policy, have news or different basically information, non-structured information. So each of them are siloed. When we access, if we want to get a full picture of a customer, basically when you say you build a customer support, or you even build an e-commerce agent, you need to understand who is this customer. The customer has a history, the customer has transaction, the customer has a certain profile, and the customer may come to your website, did some transaction before. So you want to understand the full picture. But now you only have each of this system, so your agent has to access each of different database, different file system to join the picture for the customer. The current system doesn't support that. It's a silo. Number two is when you load a joint picture for the customer, essentially you are doing a batch processing. You are actually, every customer visit, you have to join, do a data join. So it's it's quite slow. And then typically nowadays, even we have I think maybe it's going to sleep. So. Okay. So typically when we have the MCP server for agent, essentially behind the MCP servers are different APIs. APIs are originally written for humans. You have API call, you can write some function to remotely call those functions. So that's not originally designed for agent interaction. Use yours. No, let's go to the top. Can we put the slideshow? Okay, And finally, the definition inside each this signode system for certain things like valuable customer it's different. There's a inconsistent. For example, just the word risk, customer, this transaction is risky, may be defined in the different rules in different kind of scenarios. So for this reason, we need to think about how we change the platform to satisfy the agent need. Number one, we want to unify the semantic access to the data. Number two, we want the data to be fast, joined together in a real-time sense. And then the interface should be agent native. Finally, the entities should have a shared definition. So that will unify the platform. So what we see here, we propose is this kind of unified data platform, or what do we call AI agent native data platform, where you have all the data set at the bottom. We call that the foundation layer, the layer one, where you have different kind of data. You have transaction data, or just some data in the cloud. You call just a bunch of mixture of data lake. You have knowledge graph. We have vector store, and then some streaming data. But the most important part is this second layer we call the core engine. The core engine is also called the semantic fabric. It brings together all the data into an understandable way for the agent to consume. Now, how do we bring it into an understandable way? It requires as in the center, I will talk about the center box. In the center is a so-called memory. The memory is a snapshot of how the data join together to form a long-term, short-term memory about this particular user, about this particular event. And so, so that's the memory. And then we have to dynamically discover how to use this memory in certain situations. For example, in customer support, in the self-servicing interaction, your memory, you use a certain part of the memory, but in the back office, when we do the investigation about a much deeper understanding about whether a case is fraud or not, you introduce more memories. And on the other hand, in the front office, for the a human being to deal with the customer, the memory will be also different. So you have a different type of, we call dynamic discovery for. So, and then the third part on the right is, which the previous speaker actually mentioned, is the so-called governance. Data governance or protocol. A protocol basically tells you what kind of data this agent can access, what kind of rules, how do they communicate with each other, what data can be shared. And we call it portable. We want that this agent can use on this particular application, but also carry that almost like an envelope, your certificate. You can interface with outside agent. You can work with your own internal agent. So the previous speaker did an excellent job reviewing the history of data. And so today we have transactional data that's just a normal database. We have collection of different type of data in the data lake. Knowledge graph is useful to understand the entity relationship. We have a vector store that create embedding so that you can access text data much faster, or even image data in a more embedding for large language model to consume. Finally, there's a lot of real-time event data, that more like data stream data. In the center, the core engine, I mentioned that there are three major functions. first, sit below this core engine are the data or all the data sources. So it connects to the data source. But it has 3 major functions. Dynamic discovery about the data. In the center is the memory, the agent memory, how it manage the memory as a context. Finally, is the governance layer. So how exactly do we do dynamic discovery? This is also called a context engineering. It's just a different term. Context engineering is a more fashionable term. So essentially, in order to understand the context, it needs to read certain kind of metadata. So there are certain data catalog allow you to read in the metadata, understand what data have to retrieve. And after that, the agent, based on the current task, so it also needs to understand the user intent, understand the task it needs to accomplish. Based on all of that, it then decide what data to connect to. And so this module needs also to be adaptive. If we add a new data source, it should immediately update its catalog, update its metadata. So in terms of memory, we divide the memory into 4 types. The episodic memory is what is happening, the event, the customer calling, and the context, why it's calling. So the event is what is happening at this moment. Procedural, on the right side, the semantic memory is much longer term. It's more about the company rules, about the facts or some policy, FAQ. All those we call semantic memory. In the procedural memory, is more about step by step what you have to do in order to handle a dispute. You ask about current transaction amount, who are the parties. So you have a procedure you have to follow. And then in the temporal part is more about the data that it's basically happening at this moment, that would change over time. Temporal part is about sequential data, so that you understand what is happening. So sorry, I went back. Now the finally is the portable governance, where we wanted the policy to travel with data. So the data protocol certainly are very useful. And I mentioned that you can think about it as an envelope that it tells you the access, privacy, how essentially people can do audit. You can carry this, the agent can go into different system, carry this into different system. We will have a track log to enable audit, also enable multi-agent interaction. So the finally at the top layer is the agents now utilize this semantic layer to do something. So this is just one example of a multi-agent system where you have 3 agents complete a certain task, do some research, write some code, and then execute the code. So the if we think about it, this is more like a flow. You go from you start with layer 1. You ingest the data. So when the agent starts, the agent needed to ingest a certain data, and after that, it goes through the semantic fabric to unify all the context for the current agent. Then you do some agent itself do reasoning query on based on the current context. Finally, then agent take action. So we mentioned that we wanted this whole process to be fast. Essentially, if we implemented this well, it should be sub-second. And this is just a quick way to say that. Knowledge graph I won't mention too much. Essentially, just saying this is just one type of data we can link the entity together. Now, the I mentioned that API was for humans. Nowadays, we're basically agent works with many we call protocols. MCP is just a protocol for tools. Now we also have A2A, that's a protocol for work with another agent outside your organization. ACP is agent communication protocol, is for agent work inside your company. And ANP is also a new proposed protocol for the agent to discover a whole network of agent outside. But it's different from A2A, where A2A is established between so if you want to do task A, you know Google has another agent that can do task B. You communicate to get a task done. AMP is more like a crawler. You crawl the whole internet to discover what agents are available, how I can use them. The flywheel is just saying when each time when the agent start take action, we have a signal. The signal will feed back into our context, our memory, and that will improve our performance. So the fundamental principle for designing a data agent native data platform is number one, semantic design. Basically, we want to unify the entities. We want to unify the understanding. And we want the system to be real time, not slow, because agent execute much faster than human, right? Human can wait for even 1 second. Agent is sub-second, and many agents are working. And the third part is we want to think about the memory as an infrastructure. So this is a new concept. The concept is going forward. We not only think about the data layer, we want to think about the memory layer. What does it mean to have a memory? For example, we talked to ChatGPT for a long time. ChatGPT now remembers each person, so they have a long-term memory of each person. And they also have short-term memory about what you are trying to do. In the future, each agent, when they serve each customer, the view we have is about the memory, so not about the data we have. And the governance, the protocol native, I mentioned that. So the evolution of this kind of platform, essentially, we are making it native. So essentially, what we propose, we are not touching the data layer. We just allow all the data exists today. We don't need to rewrite, but we need a fabric, bring them together. So that's the basically the message for this talk. And finally, what we are saying is we are ready to implement that for your company, for each company, because architecture is very well established. The protocol, all the protocol are available, and the roadmap is clear. So for example, we can start to audit the gap between the entity semantics and use MCP to start, then start to build the memory. I think before you do context engineering, understand how to implement the memory for your company. All right, that's it. Thank you.